Okay, so let's work on series to sigma notations. So a series is a series of numbers that are being added together. So for example, we could do um, one. Or let me. We do 1 plus 2 plus 3, and we could keep going till we get to 100. Right. And again, right, we see multiple numbers that are going to be added together. And so we can represent this through sigma notation because we understand that this series is just repeated addition. So we can use sigma notation, right? And then with this, right, we can start off with, in this case, it wouldn't really matter because we would be, we would, we would just be adding zero either way. So in this case, we could still start off with, let's start with zero. And then we could represent this as I and then 100. So this sigma notation would be equal to this series, right? Because we would be plugging in zero, and then we increment the I by one. So then this would just be one. And then we increment the one to two, increment it to three, four. Oh, and then this would be addition. And then we would go so on until we get to 100. And then from then on, right, because we have this number on top of the sigma notation, right, once we get to 100, we stop. We don't go beyond that point, right? And this is how you get a series into sigma notation. However, you could also represent this differently through this, through just changing the index at the bottom of the sigma notation. So rather than going from starting from zero, you can start from one, right? And then we can still do I, right? And in this case, we would still go from 100 because then now we're just not going from zero. Now we're just starting from one, and then increment it two, increment it three, and then we keep incrementing till we get to 100, and then that would be 100. Okay, with this example, we understand it's a series, right? Because we have a series of numbers and they're being added together. And we understand when we look at this that starting from 5, there's some sort of factor that is being added to 5 to get to 122. So if we start by the first number and then we look at the second number, we understand that we're adding 3 to 5 to get to 8, right? So we could, and we're adding 3 to 8 to get to 11. So we understand that we're incrementing by threes every time. So we can represent this by 3 I, right? Because or you know what? To make it easier, we'll just do n. So we're adding 3 some amount of times to 5 to get to 122 or 122. However, we don't know how many times we're adding 3 to 5 to get to 122. So we can solve for that. So we can set this equation that we set up equal to 122, right? And then we subtract 5 from both sides. We're left with 117 is equal to 3n. And to isolate n, we have to divide by 3. And we're left with n is equal to 39. Okay, so now we understand that to get to 122, we're going to have to be adding 3 to 5 a total of 39 times. So now that we have all this information, we can convert this series into a sigma notation. So we set up our sigma notation, right? All right, let me draw that a bit better. Right? We can start out with n is equal to 0, and then we're adding again. We're adding 3 to 5 a total of 39 times, and that's it. Just 39 times and we're done, right? Unless this series was to keep on going, right? But it doesn't because it just caps at 122. We're just stopping at 39. And we're doing this equation, right? What we did here. So we're just going to write this here, right? 5 plus 3n. And now this is equal to our series, right? Okay, let's work on one last example. So if we have the following series, right? If we have here, right? We're starting off with 9, and we're adding 16, adding 23, and going on, so on, till we get to 114. Okay. Again, the first thing we want to look at is how much are we adding to 9 to get to 16? So from this, we understand that we're adding 17. I mean, sorry, a 7, right? And then we go into 16. How much are we adding to 16 to get to 23? And again, we see we're adding 7. So therefore, we understand that we're adding 7 to 9 some amount of time, right? We're adding this, we're adding 7 to 9 some amount of times till we get to 114. However, we don't know how many times we're going to be adding 7 to 9. So we're going to solve for the amount of times we will be adding. So, right, let's solve for n. So we subtract 9 to both sides. We're left with 105 is equal to 7n. Then we divide 7 to both sides. And then we get 109 divided by 7 and then we're left with n is equal to 15. Oh, sorry. Right. Um, this is not meant to be addition. This is meant to be subtraction. There we go. Okay. So now that we have that, we're adding 7 to 9, a total of 15 times to get to 114. We understand that this is stopping when when n is equal to 15. Or once n is equal to 15, we're not adding 7 anymore. And then we're starting at 0. Okay. And then now we just use the equation we made here. 9 plus 7n. And again, this is our conversion from the series into a sigma notation. Again, you can have different versions of this sigma notation. However, it would just require you to change your starting index and your ending number. And then it may also require you to change around your equation because now you're starting and ending at different values, which can affect your final number, your final number that is the addition of all the series, of the whole series, basically. Uh, and yeah, I hope you found this video helpful. If you need more help, check out my channel. I have more content about series and calculus. And yeah, if you liked and enjoyed, please make sure to support. Thank you.